In this video, we will discuss non-homogeneous and homogeneous linear equations. Equations of the form x plus y equals 1, 2x plus 3y equals 1, 5x minus y equals 11 are non-homogeneous linear equations because here the right hand side of these equations is non-zero. Similarly, linear equations x plus y plus z equals 3, x plus 2y plus 3z equals 4, x plus 4y plus 9z equals 6 are also non-homogeneous linear equations because the right hand side of these equations is non-zero. On the other hand, linear equations of the type x plus 2y equals 0 to x minus y equals 0 are homogeneous linear equations because the right hand side of these equations is 0. Similarly, linear equations x plus y plus 2z equals 0, x plus 2y plus 3z equals 0, x plus 3y plus 4z equals 0 and 3x plus 4y plus 7z equals 0 are homogeneous linear equations because the right side of these equations is 0. So we can easily recognize non-homogeneous linear equations from homogeneous linear equations. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Let us understand what is echelon form of a matrix. And first, let us understand what is a row echelon form of a matrix. A matrix of the form 4 2 3 7 0 3 5 8 0 0 6 1 0 0 0 minus 3 is called a row echelon form because here the elements in the first row are non-zero. The elements in the first column below this 4 are all 0. Then elements below the second element of the second row are all zeros. And the element under the third element of the third row is 0. Or a matrix of the form 1 minus 2 3 6 0 0 3 minus 5 0 0 0 0 0 0 0 0 is also called a row echelon form of a matrix because the first row is non-zero. Elements under the first element of the first row are all zeros. Then under the second element of the first row are also 0 and the elements below the third element of the second row are all zeros and that below the fourth element of the second row are also 0. Now we will see how we can convert a given matrix A B C D E F G H I J K L M N O P into a row echelon form. First, we have to plan row transformations in such a manner that the first row is non-zero. Then we make elements below the first element A, that is EIM, equal to 0. Then we try to make elements I and J equal to 0 which are below F. Then we try to make this O element 0 which is below this K, and finally we try to make this P 0. In this procedure we might get the row echelon form even in 2 or 3 steps or in more steps. Now we will see what is column echelon form and how to get it. A matrix in the form 1 0 0 0 minus 1 2 0 0 1 minus 1 0 0 1 minus 2 0 0 is called column echelon form of a given matrix. Here we observe that this first column is non-zero. Elements to the right of first element of the first row 1 are all zeros. Then elements to the right of the second element of the second row are all zeros. Similarly, elements to the right of the second element of the third row are all zeros and elements to the right of the second element of the fourth row are all 0. In order to get a given matrix A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P in the column echelon form, we have to perform only column transformations. We first have to make all the elements to the right of the first element A 0, then all the elements to the right of the second element F of the second row 0, then element L which is to the right of element K 0, and finally this element P 0. You can get this column echelon form in 2 or 3 steps or in more steps depending upon the numbers in the given matrix. Now let's understand what is meant by coefficient matrix and augmented matrix. Suppose we have 3 linear equations in 2 variables such as x plus y equals 1, 2x plus 3y equals 1 and 5x minus y equals 11. We know how to write these linear equations in a matrix form. We write these equations in the matrix form as Ax equals b, where A is coefficient matrix and B is matrix of the constants. So we write these 3 equations in the matrix form as 1 1 2 3 5 minus 1, then xy equals the matrix of constants 1 1 11. Suppose by row transformations we converted this coefficient matrix into a row echelon form as 1 1 0 1 0 0 and performing similar operations on this constant matrix, we got matrix 1 minus 1 0. Then the matrix containing the elements of the coefficient matrix and the matrix of the constants, which we write like this: 1 1 1 0 1 minus 1 0 2 0 is known as augmented matrix, and we denote this augmented matrix as A B. We will see how to find rank of a matrix from its echelon form. In the row echelon form of a matrix 1 3 2 2, 0 minus 1 minus 1 1, 0 0 1 minus 2, 0 0 0 0. There are 3 non-zero rows, therefore the rank of the matrix is 3. In the column echelon form of a matrix 1 minus 1 1 1, 0 2 minus 1 minus 2, 0 0 0 0, 0 0 0 0. Here the number of non-zero columns is 2, hence the rank of the matrix is 2. We will talk about condition of consistency of a system of linear equations. If number of equations equals number of unknowns in the equations, then the matrix of the coefficients is a square matrix, and if the determinant of the matrix is 0, that is, if determinant of matrix A equals 0, implies that the equations are inconsistent, which means they do not have unique solution. If, however, if the number of equations is less than the number of unknowns, the system of equations Ax equals b is consistent, that is, possesses a unique or infinite solutions, provided that rank of the coefficient matrix A equals rank of the augmented matrix A comma B. Now we will see what are the things involved in solving non-homogeneous linear equations. Consider a system of non-homogeneous linear equations written in the matrix form as Ax equals b, where A is the coefficient matrix, x is the matrix of unknowns, and b is the matrix of constant terms. Now we have basically two cases. In case 1, if rank of coefficient matrix A is less than rank of the augmented matrix A comma B, then it implies the equations are inconsistent. That means they have no common solution. In case 2, if rank of matrix A is equal to rank of the augmented matrix A comma B, it implies that the equations are consistent. That means they possess a solution. Further, if rank of matrix A equals number of unknowns, then the system has unique solution. In such case, determinant of matrix A is non-zero, that is, it is a non-singular matrix. If rank of matrix A is less than number of unknowns, it implies the system of equation has infinite solutions. Here n minus r unknowns called parameters can be assigned arbitrary values, and the remaining unknowns can be expressed in terms of these parameters. Here R represents rank of matrix A and n represents number of unknowns. Now we will solve some non-homogeneous linear equations and see how these cases can be applied in them. Let us solve linear equations x plus y equals 1, 2x plus 3y equals 1, 5x minus y equals 11. First, we will check the consistency of these equations. For that, we have to find rank of coefficient matrix A and rank of augmented matrix A comma B. First, let's write the equations in the matrix form. 1 1 2 3 5 minus 1 into xy equals 1 1 11. We will convert matrix A into row echelon form by performing row transformations. So first R2 minus 2R1 and R3 minus 5R1 gives the first row as it is. Second row 2 minus 2 0, 3 minus 2 1, 5 minus 5 0, minus 5 minus 1 minus 6, 1 as it is, 1 minus 2 minus 1, 11 minus 5 6. R3 plus 6 R2 gives 1 1 0 1 0, minus 6 plus 6 0, 1 minus 1 6 minus 6 0. Now this is the row echelon form of matrix A. Number of non-zero rows in this matrix is 2, so its rank is, there are 2 non-zero rows in this matrix, 1 1 0 1 0 0, 1 minus 1 0. Here number of non-zero rows is 2, hence a rank of augmented matrix A comma B is also 2. Since these two ranks are same, it implies that these equations are consistent. Moreover, since rank of matrix A equals number of unknowns n, which is 2, this implies that these equations have unique solution. Now from this equation 1, we can write the equations as matrix multiplication gives x plus y equals 1 and y equals minus 1. That gives x minus 1 equals 1 or x equals 2. So x equals 2 and y equals minus 1 is the unique solution of this system of equations. Solve non-homogeneous equations. 5x plus 3y plus 7z equals 4, 3x plus 26y plus 2z equals 9, 7x plus 2y plus 10z equals 5. Let us write these equations in the matrix form. 5 3 7, 3 26 2, 7 2 10 into x y z equals 4 9 5. Because of this 5 and this 7, let us perform 7 R1 and 5 R3. That gives 35 21 49, 3 26 2, 35 10. Same operations here, 28 9 25. In order to make this 35 0, we will perform R3 minus R1, and to convert this 3 into 0, first we will perform 5 R2. So that will be 35 21 49 15 130, 10. R3 minus R1 will give 35 minus 35, 0. 10 minus 21, minus 11. 50 minus 49, 1. 28, 45. 25 minus 28, minus 3. Now we will make this 15 0. So we perform R2 minus 3 upon 7 R1. So that will be 35, 21, 49, 15 minus 15 will be 0, 130 minus 9, 121, 10 minus 21, minus 11, 0, minus 11, 1, 28, 45 minus 12, 33, minus 3. Now in order to make this minus 11 0, we will perform R3 plus 1 upon 11 R2. So that will be 35, 21, 49. 0, 121, minus 11, 0, minus 11 plus 11, 0, 1 minus 1, 0, x, y, z equals 28, 33, minus 3 plus 3, 0. We will reduce the first row by 1 upon 7 R1 and R2 by 1 upon 11 R2. So 5, 3, 7, 0, 11, minus 1, 0, 0, 0, 4, 3, 0. Now this is the row echelon form of matrix A, and since there are two non-zero rows in matrix A, its rank is, here number of unknowns is 3, and since rank of matrix A is less than number of unknowns 3, it implies the equations have infinite solutions. We write the equations in 1 by matrix multiplication as 5x plus 3y plus 7z equals 4, 11y minus z equals 3. We have to assign values to n minus r variables, that is 3 minus 2, one variable, and we will assign a value t to this variable z, and we will express the values of y and x in terms of this t. So from this equation we get y equals 3 upon 11 plus t upon 11. Now we will use this value of y to find the value of x. So substituting this value of y in this equation, we will find the value of x. So we write 5x equals minus 3 times 3 plus t upon 11 plus 70. So that will be minus 9 minus 80t upon 11. So that gives value of x equals minus 9 upon 55 minus 16t upon 11. So here we got the value of x, value of y, and value of z in terms of t. Here t is called parameter. We have to find the value of lambda, for which the linear equations x plus 2y minus lambda z equals minus 1, 2x plus y plus z equals 2, 3x minus 2y plus lambda z equals 1 will have no unique solution. First we will write the equations in the matrix form. So we write 1, 2 minus lambda, 2, 1, 1, 3 minus 2 lambda into x, y, z equals minus 1, 2, 1. In order to make this 2 and this 3 0, we will perform row transformations R2 minus 2 R1 and R3 minus 3 R1. So that gives 1, 2 minus lambda, 2 minus 2 0, 1 minus 4 minus 3, 1 plus 2 lambda, 3 minus 3 0, minus 2 minus 6 minus 8, lambda plus 3 lambda, 4 lambda. X, y, z equals minus 1, 2 plus 2 4, 1 plus 3 4. We know that the equations have unique solution if the coefficient matrix is non-singular, which means determinant of coefficient matrix A is not equal to 0. Solving this determinant by column, we write this 1 into minus 12 lambda plus 8 plus 16 lambda plus, because of these two zeros, 0. That should not be equal to 0. That means 4 lambda is not equal to minus 8, that is lambda not equal to minus 2, which means that the equations will have unique solution when lambda is not equal to minus 2. But we have to find the value of lambda when these equations have no unique solution, which means we have to assume lambda equals minus 2. This matrix equation becomes 1, 2, 2, 0, minus 3, 1 minus 4, minus 3, 0, minus 8, minus 8. We will make these two elements 0 by row transformation. R3 minus 8 by 3, R2. Therefore, 1, 2, 2, 0, minus 3, minus 3. 0 plus 0 will be 0. Minus 8 plus 8 will be 0. Minus 8 plus 8 will be 0. Minus 1, 4. 4 minus 32 upon 3 will be minus 20 upon 3. Now, the last equation gives 0x plus 0y plus 0z equals minus 20 upon 3, which is absurd. Also, rank of coefficient matrix A is 2, which is not equal to rank of the augmented matrix A comma B, which is 3. So it implies the equations are inconsistent. Therefore, when lambda is minus 2, these equations have no unique solution. We have to discuss for what values of lambda and mu the equations x plus y plus z equals 6, x plus 2y plus 3z equals 10, x plus 2y plus lambda z equals mu have A. No solution, B. A unique solution, C. Infinite number of solutions. Let's write these equations in the matrix form. 1 1 1 1 2 3 1 2 lambda x y z equals 6 10 mu. By row transformations R2 minus R1 and R3 minus R2, we will convert this 1 and this 1 0. We get 1 1 1 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, 1 minus 1 0, 2 minus 2 0, lambda minus 3, 6, 10 minus 6 4, mu minus 10. We have to check for unique solution. This coefficient matrix should be non-singular, which means determinant A not equal to 0. Let us solve this determinant by column. That gives this 1 multiplied by lambda minus 3 minus 0. These two zeros will give zeros. So this is not equal to 0 or lambda not equal to 3. Now when lambda not equal to 3 while mu has any value, these equations will have unique solution. Now suppose lambda equals 3 and this mu minus 10 equals 0, mu will be 10. So in this matrix equation, rank of coefficient matrix A will be 2. For lambda equals 3, lambda minus 3 will become 0. So there will be 2 non-zero rows. So hence the rank will be 2. And rank of augmented matrix A comma B, when mu equals 10, it will be 0, will be 2 because there will be 2 non-zero rows in the augmented matrix. Since these two ranks are equal, we conclude that these equations will be consistent and the system of equations will have infinite solutions when lambda equals 3 and mu equals 10. Now in the third possibility, if lambda equals 3 and mu not equal to 10, rank of augmented matrix A comma B will be 3 because in that case there will be 3 non-zero rows in the augmented matrix. And when rank of coefficient matrix not equal to rank of augmented matrix, it means that the system of equations will not possess any solution or no solution. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.